All right, so in this video, I wanted to demonstrate the actual OR functionality and also actually putting in our own custom value. So if I do tpm2 PCR read SHA-256, basically I took this string, which is a random SHA output, and I combined it with all the zeros that, are here and then did a PCR extend. So it'd be an extension with all these zeros. And we're going to say that this is, what we expect the system upgrade to look like after we do a firmware update. So I'm going to go ahead and do a reset on 23 because the only reason I was using that was to get the actual hash value that we would expect. So now you can see it's back to 0 along with everything else. This is what we start out with when we start up the TPM. So I clear this. The other thing I've done already is I created the storage root key. So if I do tpm2 get cap handles persistent. So if you watched the last video, I did all of the same steps up until the point where I put this in persistent memory and removed it. I did the flush to get rid of it from the transient memory. What I haven't done yet is create the storage key or the policy for the storage key. So again, just doing a little bit of copying and pasting here. Start the auth session. Here, this is what I did last time. So we have tpm2 policy PCR, and I'm going to do the same thing here, except here I'm just going to do 0, 1, and 2 because the values of 0, 1, and 2 right now are all zeros. And again, a lot of this was explained in the last video. I'm just kind of demonstrating the actual functionality and one small change. So I'm going to go ahead and remove that session file. So now in the last video, what I did was the tpm2 PCR extend, but what I want to do this time is actually give it a custom value. So when I looked at the PCR bank, this was the output that I got. It's in hexadecimal. So what I want to do is write that to a file. And that's a pretty long, kind of ugly string. It's not really complicated. It's just a lot of stuff. So I'm just going to paste it in. I'm going to go ahead and just do this command and then talk about it afterwards. But if I do xxd and then expected PCR dot data, this is what the hex version of the data file would look like. You have, your base address of zeros, and then you have 16, 32, 48, 64, and so forth. Here, again, remember, I'm doing SHA-256 on 3 different PCRs, so we need to have 3 of them. So there's 2 of them for each individual hex value. So again, recalling that this was what we had, but we can only fit 16 hex characters on each line. So this is the address. This is the first part of the string all the way up until 1964, and then we just, go on to the next address. So basically what I'm saying is we expect PCR 0, 1, and 2 all to have this value right here. So just recapping, that's all I've done here is I put in the address, and then this is the actual hex value. I have a new line there to do a line break, which is why I have the flag for E, which allows me to put in the new line. Here we're just using XXD, which will translate hexadecimal. So if I do XXD on a file such as secret, it gives you the hex output. And then here we're just writing to the expected PCR data file. So all I'm doing is creating a file to store what we expect our PCR values to be. Now, I don't know for a fact that we need to create a file. We might be able to do this by storing this value in main memory. We would just have to figure out how to take in that input from a user and convert it all into this type of format. So just recalling, I already have my policy1.pcr. Now I'm going to create my policy2.pcr. So again, just copying and pasting. But instead of taking in the values of these PCRs, what we should be able to do is, so again, I'm just copying and pasting here. So again, this is going to be 0, 1, and 2, but what we should be able to do is also pass in that file, which is called expected PCR date. And then again, I'm going to flush the context, RM session. This time we're going to create the policy or combining those two, flush it again. I'm just going through all the commands I went through on the last video. The only things I'm explaining are the things that are different. And once again, creating the storage key, but we're going to be using the policy.or, and I'm using the parent handle from inside of the TPM that we persisted, the storage root key that we stored in persistent memory. And then now, hopefully, if I did everything correctly, 0, 1, and 2, and then use the policy or Again, I haven't changed anything. We set the policy based on the PCR that we have right now. And it did work. It gave me the unsealed version of what I had saved. And then just to show you one more time, these are the current values of the PCRs, which are all zeros at the moment. So that is one condition that should satisfy the PCRs. So the other condition was assuming we combine 0 with the SHA-256 hash, and we're going to do that for all three of the PCR values this time. So I'm just extending 0, 1, and 2, and then again, TPM PCR read SHA-256, and we wanted those to all be the same hex value that we wrote in, so that looks good. And for good measure, I'm going to go ahead and delete that session.context and flush context. And one more time, I'm going to do an auth session policy PCR. We're using the 0, 1, and 2 PCRs, policy OR. And again, we have my awesome secret, even though I changed the values of the PCRs. So the OR condition worked. Either everything was all zeros or everything had the hash values that we gave it. And just to demonstrate that it wouldn't work, if I did another PCR extend, TPM2 PCR extend. Let me TPM2 PCR read SHA-256. Again, we can see that the value of 0 is now not what we expected it to be. It's not what we wrote into this data file. So, we're pretending somebody is, trying to access it with a different PCR value, which we don't want them to have access to the file. And one more time, just for good measure, I'm going to go ahead and flush context and remove session, and then start my final auth session. And then here I'm going to try to do my policy OR, and this is where it fails. And I actually would have expected it to fail afterwards. Not entirely sure why that is, because I figured we would try the TPM2 unseal. And if I do a TPM2 unseal, you'll see it does say that, well, actually it says we're out of memory. So real quick, let me look at TPM2 get cap handles transient. You can see we have 3 items in here. So I'm going to go ahead and flush one of those and then try that one more time with the unseal. And now it says very specifically that a policy check failed. Although you can see up here, it failed when we tried to do the policy OR. And I'm not entirely sure why that is, but if you do if you look at the help under policy OR, they actually have an example of this. So here they did the exact same thing I did. They did a PCR extend to emulate the tampering of the system software, and then they did an auth session. They created the policy PCR, and then here they're trying the policy OR, and this is where they're saying that it should fail before they even do a TPM unseal. In fact, they don't even do a TPM unseal in this example. And then here they do the reset, and then they try to create the policy OR and then unseal it. So that should be working as intended. We just need to figure out how to turn all of that into C code. So I think we just need to add an extra argument or something. So when we do a kmyth seal, the user can pass in, I guess, their hexadecimal values. We'll just take them one by one. So it's worth noting that in the hex file, these are just taking a bunch of hexadecimal values and storing them. So in the example I did, I used, 0, 1, and 2, but I could have, done 6, 7, and 8, or, 6, 10, and 23. And it would always, write the first, and I believe it should assume that this first set, and I believe it should be assumed that the first set of hex values belongs to the first thing in the PCR list. And then, the second set will belong to the 10, and the third set will belong to the 23, or, whatever it is that you pass in.